this OpenGL video, and in this video we are going to draw our first triangle, and I'm also going to explain some concepts here and there so that we can get the fundamentals of OpenGL. And I'm going to use this code here called triangle.cpp to explain some basic fundamentals and what we are going to be doing in this series of OpenGL, and we are going to build up from these fundamentals. So I'm going to start with also I'm going to explain what you call the graphics pipeline, a bit of it, and then I'll have another dedicated video about it where we're going to deal with the graphics pipeline alone. So what do we have here on our screen? This is a code that renders a triangle, and we are going to run it after I have finished explaining the elements in this code. And as you can see here, we have, this is our vertex shader, and I'm also going to explain what's a vertex shader, what's a fragment shader as we go by. But this determines the color, and the vertex shader determines the position of our triangle. So when we're installing OpenGL, there are some helper files that you will need, that you will install. I'm also going to show you how you can install these files in a later video. So let's just deep dive to our code, and I'll start explaining the code little by little as we understand. So before I go into explanation of the code, I'm going to explain to you what we call a normalized device coordinate, NDC. So in the graphics pipeline, once your vertex data has been processed, I believe your vertex data being processed is usually the first step of the graphics pipelining. So once your vertex data has been processed in the vertex shader, it must be normalized. It must be in a normalized device coordinate. This is a small space where the x, y, and z values range from -1 and 0 to 1, 0. Any coordinates falling outside this range will be discarded and clipped, and it won't be visible on your screen. So the center of this coordinate is usually 0, 0, because we are dealing with what you are seeing on your screen in 2D. So it won't have three axes. It's going to have two. So it's going to have a 0, 0, and the axis point in the standard Cartesian direction. So what is a vertex buffer object? We have to understand these terms so that when we are going to the code, you are going to understand what these things are. So the vertex buffer object is usually sends data from the CPU to the GPU, and it's relatively slow. So we can use vertex buffer objects to send large batches of data at once. In terms of memory management, VBOs are memory objects in the GPU's RAM that stores your vertex data, and they usually have a buffer ID. So every VBO is assigned to a unique ID using the GLGen buffers, which allows you, this is a code, a C++ code. You're going to see it in this code, which allows you to manage multiple buffers within the OpenGL context. I have it here. So when this is after we've initialized our float vertices. These are the points that will be used to draw the triangle. So the GLN buffer is here, and as you can see, as as you can see, that allows you to manage multiple buffers within the OpenGL. In our context, I'm going to explain what it means there. And then we have what we call the binding. Binding, before you can perform an operation on a buffer, you must bind it to a specific target. For vertex data, you must bind it to a specific data. So for vertex data, this is a GL array buffer. The GL array buffer is here, this one. So the before you perform operations on a buffer, so this is what our buffer has been binded to, this GL array buffer. So the GL buffer data, this one, this command that actually performs the memory copy from the CPU to the GPU, and it requires 4 parameters. So this GL buffer data requires 4 parameters: the target, the type of buffer, the size of the data in bytes, the data, the actual pointer to the data, and the usage, a hint to the graphics card on how to manage the data internally. So understanding the usage patterns, we have the GL static draw. In our case, we are using GL static draw. This is used if the data will not change at all or rarely. For example, in a video game that has a mountain range, the mountain range does not change. So when the GPU is drawing it on your screen, it uses the GL static draw. You have the GL dynamic draw. Use this if the data will change frequently. Example, a character moving. And the GL stream draw. Use this if the data changes every single time it is drawn. So we are going to see a code and explain to you how we draw this triangle, the points that define the triangle. So these are float vertices at the points. These are the points, they define the vertex data and the triangle coordinates in our NDC. Remember, NDC is a normalized device coordinates. So after that, so I'm going to explain. The array vertices contain 3 sets of coordinates representing the 3 corners of a triangle. Since OpenGL works in 3D space, each vertices has an X, Y, and Z components. So all values between -1 and 0 and 1 and 0 are adhering to the normalized device coordinates. And generating the buffer ID, OpenGL will manage buffers through a unique ID numbers. An assigned int VBO, we have it here, this one. So this is a variable that has been declared to store that ID, and the to store that ID. And the GL buffer one, this one here, over here, this is, it asks OpenGL to generate one buffer object, one, you see the one here, and stores its ID in the VBO variable. So this is our VBO variable. For our case, we have 2 variables. We have the VBO and the VAO. I'll explain what the VAO is. So in OpenGL, you often need to bind an object to a specific target before you can configure it. So the GL bind buffer, it tells OpenGL that from this point forward, any operation on the GL array buffer target should affect our specific VBO. So any operation on this will affect this. So transferring the data to the GPU, we are going to have our target, which is the GL array buffer. Specifies the buffer type and the currently bound, the size of the vertices, the data, the vertices, and the usage. A hint to the GPU on how it's going to draw. So in our case, we are using the GL static draw. and I've explained what the GL static draw means. So in so this array refers to vertex attribute. So it's an array of data where each entry contains information about a vertex, like the position, the color, or the texture. The term GL array buffer is a built-in constant defined by the OpenGL library. So this is a built-in constant defined by the OpenGL library. It tells the OpenGL the data I am about to send is an array of vertices and attributes. And remember, any action that is done on that data will affect our VBO. So, so I've explained the main code that will help us write our triangle, and you're going to see it as I'm going to run this code. The other code that you are seeing here, they look very foreign. These ones here, like these ones. I'm going to explain them in another video, as these ones, all of them are in this file called main.cpp, and their functions is to draw the black window where our triangle is drawn. It's like draws a canvas where the triangle is going to be to be drawn, or it initializes a canvas where the triangle is going to be drawn. So uh, as in this video, we are just focusing on the triangle. In the next video, I'm going to explain the graphic pipelining properly. I'll have a dedicated video about the graphic pipelining from the first to the last. And I'm also going to have another video that will explain this main CPP, how it works, the component that it needs, explain how this code works, and how our black canvas is drawn, and how we can manipulate it, like change the color, stuff like that. So let me execute this triangle.cpp so that we can witness our triangle being drawn on the black canvas that is I've just shipped the code from main CPP to the triangle CPP, and you can watch. So the other codes will just talk about compiling the headers, the positions, the vertex position. I'll explain everything, and I hope you are going to watch this series of OpenGL. Subscribe to my videos and wait for other good videos that will be coming about this series of OpenGL. Thank you.